Hello students, welcome back to my channel. Today, as you can see on the board, we are going to learn class 11's chapter number 6, that is linear inequality, and this is the first session of the chapter linear inequality. Before this, we have completed the first chapter sets. If you want to check it, you can go to the description box and the links will be given over there. So without further delay, let's get started. Chapter number 6, that is linear inequality. So first we need to know what is inequality. Okay, the word inequality, you can see it is inequality, right? Now equality everybody knows already. We till today we have dealt with only equality sign. We haven't done normal calculations with inequality signs. Rather, we have used inequality signs everywhere. So what are inequality signs? Equality sign, everybody knows this is equal sign. Inequality signs, so that symbols must be known first. First one, this is greater than. Then this less than. This one greater than or equal to, and this is less than or equal to. Now these two symbols are called strict inequality symbols. These two are called slack inequality symbols. Strict and slack. Okay, now these are the symbols. Inequality, it can be done with numbers, it can be done with variables. Okay, suppose you all know that 5 greater than 3, right? 5 greater than 3, or something, suppose minus 2 less than 1. So these type of inequality expressions where we are getting everything in numerical, that means numerals, that is 5, 3, numbers, normal numbers, then we call these inequalities as numerical inequalities. Okay, numerical inequalities. So numerical inequalities are those expressions of inequalities where only numbers are there, numbers are present. Okay, this is first one. Now suppose I am giving 2x less than minus 3. You can see this is obviously an inequality. Now this particular inequality involves one variable. So whenever we are getting any variable in the inequality sign, we will call it as literal inequality. We will call it as literal inequalities. Okay, as the inequality already I have written, I'm not writing over here. So this is literal inequality where variable is present, and this is numerical inequality where only constant terms, that is the numbers, are present. So this is two types of inequalities. Okay, now inequalities can be expressed in different forms of numbers and the variables. Okay, think about that what I wrote, 2x less than minus 3. This is a literal inequality in one variable because x is there. This is literal inequality in one variable. Think about ax plus by greater than c. You can see this is also a literal inequality, and this is literal inequality of two variables. What are the variables? X and y. So this is obviously literal inequality. Why literal inequality? Because x and y are present as variables, and as two variables are present, that's why this is called literal inequality in two variables. And the variables are x and y. Okay, so these are two different types of. You can now construct your own. Suppose this one greater than or greater than equals to b, like this. Anything you can construct. Then we will tell this one what? This is quadratic inequality. Obviously these two are linear inequality, literal inequality, but this one is linear inequality. This ax plus by greater than c, this is linear inequality in x and y. Okay, this you need to know. Now everybody knows what is the linear form. Linear form means the variables degree will, not the variables, the expressions degree will be 1. That means the maximum power will be 1. It can be in one variable, it can be in two variables. So we will not go to this quadratic inequality or more than that. We will just do for linear inequality, because this is our syllabus. Linear inequality in two variables, linear inequality in one variable. Okay, now we will be doing some of the examples so that the concept can be better. So I have my book and we will be solving some of the questions, and that is from exercise 6.1. Exercise 6.1 questions will be there on your screen, and you can open your own book also. Now the first question that I am seeing here, exercise 6.1, that is number 1, solve 24x less than 100. This one you need to solve, 24x less than 100, right? This is very simple, but before we solve these things, we need to, can you see it? I think the light is not properly coming here. Wait, I hope now. Yeah. So before we go to this, we need to know some of the rules for calculating inequalities. Now equal sign and unequal sign. For equal sign and for all inequality signs, what are the main difference? For equality sign, you think about ax equals to b. Okay, I'm just giving examples so that your concept will be more firm. So x plus b, x equals to b, and you can add or subtract anything to both sides, right? Suppose x plus 2 equals to b plus 2. X minus 2 equals to b minus 2. Right? And you can multiply or divide any number from both sides. Like ax by 2 equals to b by 2, or minus 2, ax by minus 2 equals to b by minus 2, or multiplication like 3ax equals to 3b, or minus 3ax equals to minus 3b. So anything you, means all four preliminary operations you can do with the same number to both sides, and there will be unchanged expression, because this expression and this expression actually both are same. Okay, so I'm just writing over here. Now for inequality sign, there is little bit difference. You can add or subtract any number without hampering its inequality sign. Okay, like suppose 2y greater equals to 5. You can add anything like 2y plus 9 greater equals to 5 plus 9, or 2y minus 9 greater equals to 5 minus 9. But here these inequality signs will not be hampered. That means it will not be changed. It will be unchanged for adding or subtracting any number from both sides. Okay, this is the first rule, rule number 1. Rule number 2, that was rule number 1 and this is rule number 2. Now I am going to discuss. Rule number 2 is, if you are, suppose the same thing I am taking, if you are multiplying or dividing any positive number, then this will be unchanged. Means I want to say that if you are multiplying any positive number or dividing by any positive number, then this will work like equal sign. Okay, the functional property will be same if it is multiplied or divided by positive number. But if it is multiplied or divided by negative number, then this sign will be reversed. That means if it is greater than equals to, it will be less equals to. If it is less equals to, it will be greater equals to. Okay, we will be doing and we will be clarifying all these 2 rules throughout our practice session. So let's start with the first question that I wrote. And this is very simple. Look, there is no negative numbers, so this sign will work like equal. So this is x less than 100 divided by 24. The normal cancellation process. by 6. That means x less than 25 by 6. Okay, 25 by 6, it means 4 whole 1 by 6. Okay, the question is 2 types. When x is a natural number and x is an integer. So number 1, x less than 4 whole 1 by 6. Now x is a natural number. For this, whether it is told in the question or not, what you will do it for sure. That is, you will draw a number line. What you have got? You have got x less than 4 whole 1 by 6. For this, you are drawing a number line. This, suppose minus infinity, I am giving it 0 here. 1, 2, 3, 4, 5. Okay. This is minus 1, minus 2, minus 3, minus 4, minus 5, and so on. So we need to have the numbers, obviously they are natural numbers, less than 4 whole 1 by 6. So what can be the possibilities? 4 whole 1 by 6 will be somewhere between 4 and 5. So before that, which are the natural numbers are present? 4, 3, 2 and 1. Simple. So x will be in the set. The answer will be in the set. X will be 1, 2, 3 or 4. That means x can be anything, either 1 or 2 or 3 or 4. So x's possibilities are 1, 2, 3, 4. Okay, clear I think. Coming to the next part of it, that is number 2. X is an integer. When we are talking about integer, that means 0 is there, negative numbers are there. So everything we will get from this side to left hand side. From this to left hand side. So the closest integer is 4. That means x such that 4, 3, 2, 1, then 0, -1, -2 and dot 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 up to minus infinity. Up to minus infinity, this will be the required set for integer. Okay. So this is for natural number. Natural number means after 0 positive integers, and only integer, that means everything is there. Okay. Positive parts, natural numbers are there, 0 is there, then -1, -2 means negative of natural numbers. They are also there. So this will be 2 answers. Understood? This is very easy, but still you need to practice on it. Coming to next type of question, where we are getting a little bit bigger parts. So this is about exercise 6.1, question number 11 I'm doing. Okay. Question number 11. The question is 3 into x minus 2 divided by 5 less equals to 5 into 2 minus x divided by 3. For this, first we need to simplify it. Simplify it to linear inequality. So we will be doing the normal calculations. How I am doing? Cross multiplication will be done with positive numbers, so there will be no changing of the sign. That means it will be 9 into x minus 2 less equals to 25 into 2 minus x. This 9x minus 18 less equals to 25 into 2, that means 50 minus 25x. From this, I am taking this one in the left hand side, 9x plus 25x less equals to 50 plus 18. From this we are getting 34x less equals to 68. Again positive numbers, so there will be no change in the sign. 68 by 34, that is equals to 2. So x less equals to 2, we are getting finally x less equals to 2. X less equals to 2, depending on this, the question is solve the inequalities for real x. Real x means the number that is real number. So real number consisting of natural numbers, integers, rational numbers, irrational numbers, negative integers, 0, fractions, everything. Okay. So x less equals to 2 we have got as the final simplification. Depending on this, what I told, you need to draw the real number line. 0, 1, 2, -1, -2 and dot dot dot. This is also dot. The condition is telling us that x less equals to 2. less equals to 2. That means it can be 2 also, or it can be anything less than 2. So we will mark at 2 first. Okay. Now as it is less equals to 2, equal sign is there. So we will save it. That means we will darken the circle. Okay. If it would be x less than 2, we would not do that. But as it is less equals to 2, that's why we are darkening the circle. And then which side? Less equals to 2, that means left hand side. So we are drawing this type of sketch. 2 parallel lines upward and downward like this, and then a bigger arrow. It means what is the range? The range of x is starting from 2 to its left hand side. So this is actually the graphical representation, or you can say pictorial representation. But you need to answer it normally in set form. So x equals to, what can be it? Y such that okay, sorry, one thing I forgot to write. Before I wrote 2 things, that is x equal to, x equals to, that will be x belongs to, x belongs to. Okay, I wrote it wrong by mistake, so please rectify it. Here also I am writing it properly. X belongs to the set, and the set is y such that y belongs to capital R, that means real number, and y less equals to 2. This is the set builder form. Already you have done in the first chapter, sets. So x will be any element of this set. Okay, did you get it? I hope so. So this is the way of doing it. Using this type of process, you can do all the questions from exercise 6.1. Question number 21 onwards up to question number 26, the questions are word problems. So for these word problems, I just want to say one thing, that you have to convert the word problem into expressions, inequalities, and then you can go with the same process that just we have completed. So exercise 6.1 you have to do by your own. Okay, so this is all about today's session, students. I hope you all have understood it, and this is very important yet very interesting chapter. So I hope you can work on it and practice it on your own. It will be very easy to you. So we will meet in the next video. Till then, have a good day. Bye bye.